Mars holds water, and a lot more of it than you'd expect. Not just frozen at the poles. Right now, deep beneath its surface, there may be enough liquid water to cover the entire planet. Here's what we found. And how. Mars. The red planet of our solar system. Roughly half the size of Earth and about 11% of its mass, this world has long captured our imagination as a place we might one day call home. And thanks to the many spacecraft we've sent its way, we've been debating for years whether life ever existed there in the past. That's exactly why searching for traces of water on Mars has always been a top priority. And here's the thing. We've known for quite a while that Mars still has water. Not in small amounts either. We know there's frozen water at the poles and at mid-latitudes, and even traces of an atmosphere. Finding frozen water isn't all that surprising, honestly. You can find ice even on Mercury, a planet scorchingly close to the Sun. At its poles, about 3 billion years ago, Mars was a drastically different world. It had a thicker atmosphere and a warmer climate, which allowed oceans and rivers to form across its entire surface. We can say this with confidence because of the large valley networks still visible on Mars today. Riverbeds, valleys, and delta-like formations that closely resemble those found on Earth. These surface features can only be explained by the presence of flowing water and rivers that once existed on Mars. The minerals hematite and goethite detected on the Martian surface serve as further direct evidence of abundant water in Mars's past. All of these surface features and minerals were identified thanks to orbiters like MRO, the Mars Reconnaissance Orbiter, and long-serving rovers like Curiosity. The layered rock formations we observe on Mars, for example, are a direct result of ancient water movement in those regions. But then, roughly 3 to 4 billion years ago, a series of catastrophes stripped Mars of all that water. Chief among them was the loss of Mars's magnetic field. For a long time, that magnetic field had shielded the planet from the energetic particles streaming from the Sun. But as we mentioned, Mars has significantly less mass than Earth, and that meant its core, which acts like a dynamo generating the magnetic field, cooled far sooner than Earth's did. Once the core cooled and the magnetic field disappeared, Mars's atmosphere became completely vulnerable to external forces like solar winds. Over time, those solar winds swept away a massive portion of the Martian atmosphere. As the atmosphere thinned, liquid water on the surface slowly began to evaporate. And with it, surface heat escaped into space, causing temperatures to plummet. In short, Mars transformed from a relatively warm, water-rich planet into the cold, barren world we know today. But here's the part we've been skipping over. If Mars once had water covering its entire surface, and even after losing the vast majority of it, some water must still remain. Where is it hiding? Could life have begun somewhere in that water? A recent study addresses exactly these questions, and its findings are striking. Liquid water still exists in Mars's middle crust, approximately 11 to 20 kilometers below the surface. And it's not a small amount. If the detected water were spread evenly across the entire planet's surface, it could cover Mars to a depth of several kilometers. We're talking about an enormous quantity of water. And an equally bold claim. Most importantly, we're talking about the present, not Mars's ancient past. So what's the evidence behind this claim? How did we find this water? The InSight lander was launched on May 5, 2018, aboard an Atlas V rocket. After a journey of roughly 6 months, it successfully touched down on November 26, 2018, in the Elysium Planitia region of Mars. InSight remained operational for 1,440 Martian sols, equivalent to 1,480 Earth days. What set InSight apart from other Mars missions like Curiosity was that it was equipped with instruments specifically designed to analyze vibrations deep within the planet. Its SEIS instrument, a dome-shaped seismometer, could detect Marsquakes and even the impacts of meteorites striking the surface. InSight also carried another instrument called HP3, which could drill into the Martian soil down to 5 meters below the surface to gather crucial data about the planet's internal heat and structure. Some of the seismic activity detected by InSight originated from volcanic activity, but the seismic waves produced by these quakes allowed scientists to gather critical data about Mars's interior. Here's how it works. At first glance, claiming there's water beneath the surface of a planet 200 to 25 million kilometers away might sound far-fetched. But the detection technique used is nearly identical to the one we use to study Earth's interior. InSight recorded over 1,300 Marsquakes over 4 years. To understand what lies beneath the surface, scientists analyzed how seismic waves travel through different materials, because the way those waves move changes depending on what they pass through. Some seismic waves can travel through solid material but are blocked by liquid regions. This same principle is also used to locate oil and mineral reserves on Earth. Scientists studying InSight's data calculated the speeds of seismic waves generated by those quakes to determine what materials exist in Mars's interior. They then built computer models simulating conditions beneath the Martian surface, calculating how different parameters, density, water saturation, and other physical properties affect seismic wave propagation. The scenario that best fit all of those seismic waves and computer models was a large water reservoir located in Mars's middle crust, just below the upper crust. We're not talking about an open ocean suddenly appearing as you dig into Mars. The rocks below the surface are fractured and porous, and those cracks and pores are filled with liquid water. These are essentially volcanic rocks, formed when molten material cooled and solidified. When the total volume of this subsurface water is calculated, it turns out to exceed the estimated total volume of water that once filled Mars's ancient oceans. That is a staggering amount of water, and this discovery offers important clues about what happened to the water that once covered Mars's surface billions of years ago. The prevailing hypothesis, as we discussed earlier in this video, was that Mars lost its water to space after its magnetic field collapsed. But perhaps a significant portion of that water seeped underground through cracks and fissures in the surface. Or perhaps the water InSight detected was always underground, and as Mars lost its magnetic field, the surface water was simply added to what was already there. We don't fully know yet how such an enormous quantity of water accumulated. Now, given that we're talking about abundant water, could it be useful to future Mars explorers? Frankly, no. At least not with current technology. The water sits 11.5 to 20 kilometers below the surface, far too deep to extract and make usable. Even on Earth, reaching depths like that is an enormous engineering challenge. That said, this discovery opens up some genuinely fascinating possibilities. These underground reservoirs could create conditions suitable for microbial life, much like the environments found at the bottom of Earth's oceans. Despite all the rovers and research missions sent to Mars, we haven't yet found definitive proof of life, past or present. And to be clear, we're not looking for intelligent life. Even discovering a single microorganism on Mars would be one of the most consequential findings in the history of the search for life in the universe. I understand this might all sound somewhat abstract, more like a hypothesis than a concrete discovery, but this research, which provides real scientific data about Mars's subsurface, could also help us better understand our own planet's still mysterious magnetic field. Every piece of data we collect about Mars's geology and magnetism gives us a chance to understand Earth more deeply. At the very least, we know Earth's magnetic field isn't in danger of disappearing anytime soon, unlike Mars's. But understanding why Earth's magnetic poles reverse every few 100,000 years would be enormously valuable for a civilization that can no longer function without electricity. Research conducted on a planet millions of kilometers away can have surprisingly direct and indirect practical implications for our own planet and even for our daily lives. That, I think, is what makes science and planetary exploration so beautiful. See you in a completely different corner of the universe in the next video. Take care.